This is not at all a prism. This is also pyramid. This is a prism, isn't it? This is a prism. Or even this is a prism. So, prism should have the base and the top in the same shape, right? So, cuboid is also a prism, cube is also a prism. These things are pyramid, where all the vertices are converging at a single point. Okay? So, whenever I talk to you about dispersion of light through triangular prism, it means triangular based prism. So, I am talking something about this diagram, triangular based. So, this is the base of triangle and another triangle is there like this, and this is only called as a prism. So, if I talk about refraction of light through prism, you have to keep the prism like this. I hope you get my point. And the light falls on which side? One side, this side. So, light comes and hits here and then gets, usually they will draw like this on this point, and then the light gets refracted inside the prism, once again coming out, and finally it gets deviated. So, in the previous class, not required for you, but I derived and showed you what is the relationship between angle of incidence, angle of emergence, angle of deviation, angle of prism. I also told you what is the meaning of angle of prism. I said you, in a prism, if light enters from here and exits from here, the angle that is enclosed by the incident ray and the emergent ray is called as angle of prism. Suppose in the same prism, light would have come from here and exited here, this will become angle of prism. If light comes here and goes here, this becomes angle of prism. Are you getting my point? So, which is the angle of prism? That is completely given by which side the light is entering and which side the light is exiting. Don't think that topmost part is always the angle of prism. No. Angle of prism is completely governed by which side the light enters and which side the light exits. Then I said you that if a light is entering a triangular prism, then first it goes, we draw a normal, it refracts, we draw another normal, and it once again refracts, and then we try to find, this is the angle of incidence, this is the angle of refraction R1, this is the angle of refraction R2. I mean, if I draw the normal here, then here R2 is there, and this is the angle of emergence, and this is the angle of prism. And if I extend the emergent ray, incident ray, then this is the angle of deviation. You don't have to draw anything now because it is very bad diagram. I have drawn it very well in the last class. Check the notes from the last class if you have missed the class. And I told you that I plus E is equal to del plus A, not at all required for school, but if you are preparing for any competitive examination, very much required. Angle of incidence plus angle of emergence is equal to angle of deviation plus angle of prism. Remember this. Okay. Now let us come to today's topic, which is important for the school examination, and give the heading as dispersion of light through triangular prism. Give the heading as dispersion of light through triangular prism. Through triangular prism. So, all of you would have seen rainbow at least once in your life, isn't it? Have you seen rainbow? Most of you? But rainbow is not something like what we draw in the notebook. Generally, if they ask you draw a rainbow drawing, what you will take? You will take 7 colors: violet, indigo, blue, green, yellow, orange, red. Put like this, draw a line like this beautifully, and then you get a very beautiful rainbow, isn't it? Which is having all the 7 colors: 1, 2, 3, 4, 5, 6 and 7. Am I right? Easy to draw a rainbow. But in real life, tell me honestly, whether you have seen any rainbow having all the 7 distinct colors in a very beautiful way? I don't think. You would have seen rainbow, but a few colors visible, not the complete semicircular rainbow also. Some loudly? Distinct means all the colors are visible to you: violet, indigo, blue, green, yellow, orange, red, everything is visible to you. Never would have happened. You would have seen some yellowish color, greenish color, reddish color, sometimes some other colors, blue color, but you would have not seen all these 7 colors clearly being visible inside a rainbow. Today, with the help of dispersion concept, we will not only understand how the prism is dispersing the light, we will also understand the reason of not seeing a very distinct rainbow during the rainy days and what are the conditions required for a rainbow to form. Can you see rainbow every day? Can you see rainbow on all the rainy days?
Sir.
Yes. Which place you are living, man? Switzerland you are there. So every day when rain happens, you are seeing rainbow. No. There are some conditions needed. Sometimes in rain you are able to see the rainbow. It should be having some daylight also, sunlight should be there. Conditions are required. If fully cloudy, raining, will you see rainbow? No. Sun, rain and your position, everything is important for seeing a rainbow. Sun may be there, rain may be there, your position may not be appropriate, you will not see rainbow. Are you getting? So today we will learn what are the conditions which are going to help in seeing a good rainbow. We are going to learn today about even sunrise and sunset. So when we see sunrise, when we see sunset, whether it is a real sunrise or real sunset, what is the meaning of sunrise, what is the meaning of sunset, everything we will learn today. And today we are going to complete this chapter, and before that we will also learn about something called as scattering of light. Interesting phenomena. We will learn about why the sky is looking blue in color and why is the sun looking yellowish in color, and during sunrise and sunset it looks reddish in color. All these things, today's class is very conceptual class. Many things that I am going to tell you today will not be in the book. Today, whatever I am going to teach you, most of the things you will not find in NCERT book. So be very attentive in the class, learn the phenomena, learn the concepts, how all these things are happening. Good, interesting things today. Okay. So first let us talk about the triangular prism dispersion. This was found by whom, you know? Very famous scientist, Newton. Newton, by doing a lot of experiments, he was the first person to observe dispersion of light. Why? His curiosity of knowing what is the color of light. So what is the color of light? You know, what sunlight, what is the color? White. Sunlight actually is white in color. If you say sunlight is yellowish in color, it is wrong. It's not yellowish in color. Sunlight is white in color. We say sunlight is white. But this white light comprises of 7 different colors. Who found this? Newton found this. And how he found this? By doing experiment and keeping a prism. Again I am repeating, when I am drawing a prism, in background you should imagine like this. Are you getting or not? Because I know many of you how you are imagining. Many of you are imagining like this when I say prism. You imagine like this. At least before the last class you imagine this like this only. But now you know this is not the prism. This is the prism which is like this, right? So in this prism, light, when light fell on one side, it got refracted inside. Reflect, not refract. First it will get refracted once, and when it is coming out, it was observed that 7 different colors were coming out. So when it was bending here and finally it is coming out, we saw that 7 different lights are coming out. Which order? Downmost was violet, indigo, blue, green, yellow, orange, red. When a white light fell on the, suppose this is A, B and C side of the prism, when the white light fell on the AB side of the prism, we observed that what is going to come out, I will give time for writing, everybody, please pay attention. What was coming out from BC side had 7 different bands of color. Since what is entering is only white light and what is coming out is 7 different colors, we can easily say that white light would have comprised of these 7 colors, and because of this prism, 7 colors separately came out. Now you may ask why. You may ask why prism is only taking out 7 different colors. Why not some other glass material? Why not every refraction is causing dispersion? I will talk about that also. So in the previous class, I made you to understand delta, which is equal to I plus E minus A. Again, this is deep dispersion concept, not required for you. This is angle of deviation. It means whenever a light ray is incident on a prism with angle I, it is going to have a deviation of I plus E minus A, right? It was observed that the angle of deviation is different for different colors of light. Yellow light has a different deviation, indigo light has a different deviation, blue has a different deviation. If you ask me why, because of the wavelengths of the light. So, I hope you know that different colors have different wavelengths, right? Visible light is in the spectrum of 400 nanometer to 700 nanometer. Aware about that? Not aware? Today you are getting aware that visible light is under which, what is the range of wavelength for them? 400 nanometer to 700 nanometer. Different wavelengths of light have different tendency to get deviated, in which violet light deviates the most and red light deviates the least. If you ask me why, I will say that violet light has the least wavelength. It has the least wavelength, and red light has maximum wavelength. Out of all these 7 color, which light has maximum wavelength? Is red. Since red light had maximum wavelength, it has the least deviation. You will understand this in again 12th standard, where they will teach you angle of deviation is inversely proportional to wavelength of light. This you will be learning in higher class only. It means more the wavelength, less the deviation. Less the wavelength, more is the deviation. So, since violet had the least wavelength, it underwent maximum deviation, and since red light had maximum wavelength, it underwent least deviation. Violet, least wavelength, maximum deviation; red, maximum wavelength, least deviation. That is the reason why white light got split into 7 different colors. So, if you ask me, can only triangular prism give me this thing? No. Any prism criteria where light is entering from one side, getting refracted and coming out from the adjacent side. For example, if you have this is actually a rectangular prism, cuboid, glass cuboid. If light enters from here, refracts, once again emerges, no dispersion will be seen. But light enters from here, refracts, and once again comes out, here you will see dispersion. So, do not think dispersion can be seen only by a triangular prism. Dispersion can be seen by any medium which allows the light to enter from one side and exits from the adjacent side, forming an angle of prism. So, in this rectangular prism also, this will be called as angle of prism only. Are you getting my point? Rectangular glass prism has both capabilities. It can create lateral displacement also, it can create deviation also. I hope you are getting a point. But a triangular prism cannot create lateral displacement, it can create only deviation. So, light which is coming and hitting the triangular prism has only one option. What is that option? It will disperse the light. Either it will disperse from here or from here. But if you are hitting a rectangular prism, it has 2 possibilities. If it comes out from opposite side, it will displace the light, not disperse the light. But if it comes from the adjacent face, it will disperse the light and it will not displace the light. Are you getting my point? Again I am repeating, this much detail is not required for you. Just for knowledge I am telling you. In school what question will be asked, I will tell that also to you. In question they will ask to draw this diagram. They will ask, prove that white light only has 7 different colors. For that what Newton did, he did an experiment to verify this. How he did? He had this prism, no? He kept in front of it an inverted prism. You know what happened? Light entered, divided by 7 different colors, right? And once again assembled and became one color and came out. Which proves that white light was only getting dispersed in 7 different colors. So, if I have 2 prisms placed like this opposite to each other and I make the white light to come through one surface, it will disperse, 7 will come out, again 7 will combine and white light will come out. So if they ask you in the examination, what experiment proves that white light has 7 colors? This experiment proves that. Two prism experiment. If they ask in the examination, draw the diagram of dispersion by a triangular prism, draw this diagram properly. Okay, and mention violet, indigo, blue, green, yellow, orange, red. And if you want to write little more, you can mention these things also. Since white light has least wavelength, it undergoes maximum deviation. Since red light has maximum wavelength, it undergoes least deviation. If it is clear to you, copy it fast. Whatever you want to copy from here, copy it fast. Should not make the light to enter here. Here also should not. Either this side or this side. Have you copied this, guys? Online people, Darshini, Mridini, Pritham, Ryan. What you want to copy, you copied? Yeah, make it fast, man. Sorry guys, I am moving in front of you from that much time. You should say no, not able to hear you. I was speaking from last 5 minutes, Darshini, Pritam and all. Okay, anyhow. So next topic that I am going to teach now to you is total internal reflection. Very interesting phenomena. So by the laws of refraction, you know that if the light is entering from a denser medium to a rarer medium, how it goes? Towards. Away from the normal. Remember this. Whenever the light is entering from a denser medium to a rarer medium, the light, how it goes? This is called as angle of incidence. This is called an angle of refraction. Prajin, saw the dream? Come back to the class, man. So, which is more, Prajin? I is more or R is more? Looks more. Should be more. Because when the light enters from a denser medium to rarer medium, it bends away from normal. So, angle will increase. Okay. So, R is more than I. What I do, in the same medium, I increase the angle of incidence. What will happen to the angle of refraction? That will also increase. Like that, if I increase for a particular value of angle of incidence, the angle of refraction may become 90 degree also. Are you getting? We increased, it also increased. Further increased, further increased. We made a particular value of angle of incidence for which angle of refraction became 90 degree. This angle is called as what angle? Critical angle. This angle of incidence for which the angle of refraction becomes 90 degree, this angle is called as what angle? Critical angle. Critical angle. Now, imagine what can happen if the angle of incidence is more than the critical angle. Light will reflect back in the same medium, following the laws of reflection. Suddenly, refraction change into reflection. I will repeat what I have told now. Whenever the light ray is entering from a denser medium to a rarer medium, it bends away from normal. As you increase angle of incidence, angle of refraction also increases. For a particular value of angle of incidence, for which angle of refraction becomes 90 degree, is called as critical angle. At critical angle, the light will graze. This is called as grazing. This phenomena is there, no? This phenomena is called as grazing. Grazing means angle of refraction is 90 degree. If angle of incidence becomes more than critical angle, then the light undergoes TIR, total internal reflection. So if you are listening to the last 5 minutes of my class, I told that if angle of incidence is less than critical angle, light will undergo refraction. If angle of incidence is equal to critical angle, light will undergo grazing. If angle of incidence is more than critical angle, light will undergo TIR, total internal reflection. So, three conditions are I is less than C, I is equal to C, I is more than C. So, for I being less than C, what is happening? Refraction is happening. For I becoming equal to C, what is happening? Grazing is happening. What is the meaning of grazing, by the way? R becomes 90 degree, nothing else. And if I is less than more than C, we are going to see total internal reflection. Now you may have a doubt, why did I call it total internal reflection? Why not reflection itself? Yes, the reason is there. I will tell the reason for that. If you are having a normal surface, suppose, and light comes, if it is a polished surface, light gets reflected. Do you agree with me? When I taught you in the first class reflection, I said you, reflection is the phenomena by which light bounces back when it hits a reflecting surface. Now, in this case, do you think that all the light rays that are hitting the reflecting surface will get reflected? No. Some light may get absorbed here, producing heat. Some light may get refracted here inside if it is allowing to refract. Some light will get reflected. So, out of 100 rays falling, 50, 60 rays may get reflected, 20 rays may get absorbed, 10 rays, 15 rays may get refracted inside. So all the rays which are undergoing, hitting the surface of the reflecting surface will not undergo reflection. Only a part of rays will undergo reflection. But in this scenario, all the rays having angle of incidence more than critical angle will definitely undergo reflection only. And that is why the name is given as total internal reflection. You know, you learn in higher class, this phenomena is only used in optical fibers. You know what is optical fiber? Heard about this optical fiber? Loudly, man. Have you heard about optical fiber? No? You know Geo fiber, Airtel fiber, ACT fiber net? Heard these things? What are those? Optical fiber, internet, optical fiber. You would have seen some places OFC, optical fiber cable. OFC works are going on. Have you heard this OFC? Hereafter you will hear, because now you have listened from me. In some place, if you go on the ground, there will be this kind of milestone, on that it will be written OFC. Hereafter you see. It means below the ground there is some wire going off optical fiber. Optical fiber cable is purely working on this phenomena only. What we are doing, you know, our data, our information, we are converting into light, and we are making it to pass in such a way that it undergoes TIR, so that 100% of my data gets transferred. See, what is fastest? Light is the fastest, I told you. Fastest thing is light, nothing is faster than light. If you want to send data at the speed of light, at least approximately speed of light, then you have to convert your data into light. But even after you convert your data into light, if you send it, it may not reach the other end, because some of the light may get absorbed, some may get refracted, only a few will get reflected to the end. For that, what is the best way? Use optical fiber cables. Earlier we used to have copper wires for internet, but now we have made wires which are made up of glass inside, where very minute, nanometer size, but what is going inside? Light signals are going, and these light signals are carrying information, and that's why you are going to get very high speed internet. Are you getting my point? So this TIR is a phenomena where the light gets reflected in the same medium if the angle of incidence is more than the critical angle. First, write this concept. I will give the definition of TIR. Write the definition. Write the definition, please. It is a phenomena. It is a phenomena. It is a phenomena because of which light reflects back in the same medium. Light reflects back in the same medium. Light reflects back in the same medium if the angle of incidence is more than the critical angle. If the angle of incidence is more than the critical angle. If the angle of incidence is more than the critical angle. Critical angle. And light is moving from a denser medium to a rarer medium. And the light is moving from a denser medium to a rarer medium. Light is moving from a denser medium to a rarer medium. Okay. Whatever you want to write from the board, take 2 minutes and write fast. From the board, if you want to write something, make it fast. Can I proceed further? If you allow me, I will proceed. Don't forget tomorrow, C is critical angle, okay. But these things will not come in the examination because it is not in the portion for you. Now let me tell you. No. It is not in portion, what I have taught now. Tomorrow math class is replaced by physics practice class. Yes, tomorrow Shrey will come to discuss the paper with you. What test you wrote on last week? Sunday you wrote some test, right? Last week. Whatever, one science test you wrote. That paper, some doubts if you have, he will discuss, and he will also solve some numericals based upon human eye. That is defects of eye numerical, I told him to solve. So tomorrow there will be a physics practice class instead of math practice class. Don't miss the class, attend the class tomorrow. What Sanjana you will miss? No? Okay, let us see. Shall I go to the next page? Fast one please, getting late. Later you write, I will put for you after the class gets over. See, I am getting short of time. So next is, give the heading as rainbow formation. Now this is something which is there in the portion. Rainbow formation. Yes. So rainbow formation, how does it take place? Please pay attention. 2 minutes of time, then I will give time for writing. So when the raindrops are falling from the sky, from the clouds, initially it has a circular shape. Water, you know, if you take some water in your hand and you throw like this, it will become water drops while going, and you make a very slow motion, ultra slow motion video. You will be able to see that water is thrown by nature, it takes spherical shape. So naturally, sphere is a more stable shape. So it takes spherical shape only, the water drops also. But when it is falling towards earth, because of the gravitational pull of the earth, the raindrop becomes like this. That's why you draw like that. When you draw drops, usually you will draw like this only, no? Isn't it? So this kind of shape of the raindrop gives it a condition for prism. And now what happens, you see, pay attention. Light is entering, it means that sun should be here. Okay. So light will enter the water drop. When light is entering the water drop, the first thing that happens is refraction, remember that. It must undergo refraction. After refracting, it will have 3 options. What are the options? Whatever rays are hitting this point, having angle of incidence less than critical angle, will come out. All the rays which are having angle of incidence equal to critical angle will graze. All the rays having angle of incidence more than critical angle will undergo TIR, total internal reflection. Now when it is going to come out from here, no, it is going to get dispersed in 7 different colors. Are you getting my point? So if you are standing here and seeing, you will be able to see the rainbow formation. Now there are not only one drop, there are millions of drops like that. Imagine from all millions of drops, rays are going and forming the 7 color. Rays are going, forming 7. All these will combine together and give you a feeling of rainbow formation. But now I'll come to the point where why are we not able to see all the 7 colors with same thickness? Because, listen very carefully, I said white light is having 7 colors, but I not said you that all the 7 colors are in same proportion. It's not like 1 by 7th, 1 by 7th, 1 by, not like that. Some light is having more dominance, some color is less. So, if you see the spectrum, in that yellow will be more, red will be more, blue will be more, green is red, less, violet will be little less, orange will be little less. So, different colors have different proportions. What proportion is more will be visible to you, and what is less may be formed very thin layer which you are not able to see from far, and you are not able to distinguish. Only if you have 7 different colors, you will be able to see, no, violet, indigo, blue, green, yellow, orange, red. But if you have something bigger and something very thinner, then bigger, thinner, all thinner things will not be visible to you itself. That is why when we see a rainbow, we don't see all these 7 colors visible distinctly. We see some colors more, some colors even not, because of the ratio of all the colors in the white light is not same. Remember this concept. Next, how will the question come in the board examination? Question will come like, what are the phenomena taking place during rainbow formation? Can you tell me? What phenomena are taking place when rainbow is getting formed? Refraction? Reflection? TIR? What is this called as? Dispersion. So, answer is refraction, TIR, dispersion. Sometimes this question comes in MCQ also. They will give a lot of options. So, if they ask you what are the phenomena which are undergoing when rainbow is getting formed, the answer is refraction, total internal reflection and dispersion. Copy it out somewhere, please make it fast. So, for rainbow to form, you must have sun, you must have rain, and you must have both simultaneously. So, only if it is raining and a sunny day, you will be able to see a rainbow formation. Sometimes it may be there. By the time it goes, yeah, for few seconds only, not much time here. You don't think hours it will be there, only for few seconds, for maybe a minute, 2 minutes, that's all. Rain stops, no, you cannot see rainbow for 10-15 minutes after that, few seconds, till you are able to see the rays from there. After that it disappears. If you use torch that is having that much light as sun, if you use a very powerful light, you can see. If it is raining and if you are having a powerful light, then it has to reflect and it will show you. You should have some place for seeing this also. So, at night you cannot see rainbow, but yes, you can see rainbow if you are having huge light and making like almost like daytime in the night also. Possibility is there, no? If light is there. Okay. Unfortunately, today also I could not finish this topic. One small topic is still remaining, scattering of light. Very slow. Tomorrow I will see if time permits, I will also come for 10-15 minutes, I will finish my class tomorrow at 6 p.m. So, tomorrow at 6 p.m. You people will have class in the same place where it happens for the practice, not here. Okay. Clear to you? Why is rainbow? Rainbow is circle. It will never be, have you ever seen a full circle rainbow? Not like that, it can never be. See, it is just reflection of light, it may be an arc also like this. It may be of this much size also. It may be of this much size also. It is actually an arc, not a circle, not a semicircle. It's an arc. Arc can have any length based upon how much area your raindrops are there. It is very difficult for you to have a very bigger arc because of the extent of raindrops in the sky. So it's purely depending upon light falling, how much raindrops it is interacting, how much lights are entering the water drop with more than critical angle. See how many things are there. Only if the light ray is having angle more than critical angle, it will undergo TIR, no? So many factors are there. If everything is satisfied only, you will get a rainbow formation itself. Are you getting? If the question comes, what are the phenomena required for rainbow formation? The answer is refraction, total internal reflection and dispersion of light. Okay? If it is clear to you, then boys can start moving first, then girls will follow.